Hello everyone, so this is the Unit 6 quiz tutorial. Let's start with the very first question. Writing the percent as a decimal. So the given one here is 0.7%, and as you can see on the right here, converting a percent means simply dividing that given number by 100. So 0.7 divided by 100. And that means when you divide by 100, since 100 has two zeros, you're going to move this decimal point 2 digits to the left. So that's why it was originally here. Moving it 2 digits to the left means it comes 1, 2 right there. So the answer would be 0.007. So that's the first question. The second question is asking us to convert the given time period to years. So this is 42 weeks makes how many years? Assuming there are 52 weeks in a year. So that's again another simple fraction. 42 weeks, since there are 52 weeks in a year, if you divide 42 by 52, so this is actually how many years this makes. So all we need to do is just simplify this fraction. So since 42 and 52 are both divisible by 2, you can simplify them by 2, and that would be just half of 42 is 21 and half of 52 is 26. So your answer would be 21 over 26. So that's since 42 weeks is less than a year, because there are 52 weeks in a year, it's going to be a fraction that's less than 1. So 42 weeks is 21 over 26. So this is the portion of a year that makes 42 weeks. So number 3 is a simple interest problem. The formula is given, I equals PRT. So these are all multiplication. The interest amount is $75. So let's just write the formula here, I equals PRT. I is given 75 equals, P is given 6,000, so it's 6,000 times. R is 5%, but make sure that you convert percent to decimal. We have to do that when solving interest problems. And 5% is basically 0.05 as a decimal, and then times T. So this is the whole equation. Everything is in the right place, and the only unknown here is T, time in years, and that's what we need to find out. So you can multiply 6,000 and 0.05. We're going to multiply 6,000 by 0.05. You can either use a calculator or use Excel. So I used Excel to do that multiplication. It's 300. So now we see that 75 equals 300t. Dividing both sides by 300 will give you t equals 75 divided by 300. And 75 actually goes into 300 4 times. So your answer would be 1/4. Actually, I noticed the answer is requested as an integer or a decimal. So 1/4 would be equal to then as a decimal 0.25, since it's a quarter. So number 4 is a question about continuous compound interest. So the formula is not given in the question, but you can find that in your course notes. The formula is basically A equals P times e to the power, so this is exponent, e to the power r times t. And e is a constant number, irrational number, which is like 2.716. So anyways, you can use again a calculator or the Excel functions to figure this out. So P is given 9,000, R is given 6.86%, and T is given 5. So all you need to do is find A. So A would be then equals, so following the formula, P times E is, there's a command for E, so EXP and then open parentheses. So that's the e function here, and then this already in whatever you write in the parentheses is going to be the exponent of e. So this is e to the power r times t, and then close parentheses. So that's your answer. So number 4, A would be round to 2 decimal places. So your answer would be, and this is a money problem, so $12,682.52. So that's your answer. So number 5 is pretty similar to 4. It's a continuous compound interest problem. The only difference is we're given A this time, but we're being asked to find P. So we're going to use the same formula here. So let's just put in what we know. P is the question here, so we need to figure out P. A is given, which is 7,400. That's A. R is 9.72%. So 9.72%, not 9.72%. T is 12 years. So to find P, first I need to calculate e to the power r times t, and then whatever the value of this whole piece is, divide A by that so I can have P. So let's over here, pay attention. Let's calculate e, which is exp, to the power, so inside the parentheses goes r times t. So this value is this whole e to the power rt. So p then would be a divided by that whole value. So a divided by this whole value. And that's going to give you P, which is rounded $2,305. So that's your answer to number 5. So in number 6, we're given the rate per compounding period. Given the rate per compounding period, find R, the annual rate. So this is a really simple problem. The interest rate is 0.625. This is actually I, 0.625% per month. And you want to find the annual rate. So if this is per month, how many months are in a year? 12 months. So if you just multiply this by 12, you get the answer. So R would be the per month rate multiplied by 12 to find the annual rate. So annual rate would be 7.5%. So number 7 is actually the flipped version of number 6. So this time they're giving you R. See the annual, so an annuity that pays 7% compounded monthly. So 7% is the annual rate. It's R. So R is 7%. We just know that this account compounds monthly. So that's not the monthly rate. It's the annual rate, but it compounds monthly. And then this goes on for 9 years. So T is 9 in years. And we don't need to know the amount that is deposited into this account. So this is just extra information, just redundant. So all we need to know, R 7%, T 9 years. So remember, I is actually, I don't know why it does that. So I is actually R divided by the number of months. So So this is compounded monthly, so we're going to divide it by 12. Just change that. So then I would be R divided by 12 because the account compounds monthly. If they said the account compounds quarterly, we would divide R by 4 to figure out I. If it said the account compounds semi-annually, we would divide by 2, etc. So since it compounds monthly, we divide by 12. So your answer would be, and this is again in percentage, 0.0058 decimal rounded to 4 decimal places. So 4 decimal places, we're gonna do, there you go, that's 4 decimal places, so 0.0058. So that's I. And then N is the total number of months, actually the compounding periods. Since this account is compounded monthly and it is set for 9 years, so then N would be 9 times 12, because for 9 years you make deposits every month. So it's 108 is N. So number 8 is finding the future value. I put the future value formula here. Periodic payments times, so this looks kind of complicated, but if you can put everything in the right place and do the calculations, you should get it. I is the interest rate per period, and that's also given. We don't need to figure out what I is from R and what N is. Everything is given, and I put them here. So the future value would be the periodic payments multiplied by, so I'm going to open parentheses here and close it, and inside the parentheses what goes is another parentheses 1 plus I, close parentheses. So I figured I completed this part, to the power N. See, it's 1 plus I to the power N, and then minus 1, so following this, and then this whole thing is going to be divided by so divided by I again, and that's it. So the answer would be, round to the nearest cent, so this is dollar, so 7,212.99. So that's your answer. In number 9, we just need to figure out the interest rate per period and the total number of periods. So if you look at the question, it says 5.8% compounded semi-annually. So that just tells me R is 5.8%. So, and since it compounds semi-annually, then I would be just R divided by 2, because semi-annual means twice a year. So your answer to I would be just 2.9%. And N would be the number of years. So this is happening for 12 years, so 12 times. How many times does this compound in a year? Twice, because it's semi-annually. So 12 times 2, 24. So N would be 24 and I would be 2.9%. I is actually requested as a decimal, not as a percent. So instead of 2.I, you need to write 0.029. So 2.9, so as a decimal, 2.9 as a, so just divide this by 100, you get the divide by 100, so yeah, 0.029. And number 10 is, it says 20 years compounded annually at this annual rate. So then N would be just 20 times 1, and I would be just 7.1. And again, as a